is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about definition and terminology based on Module 5, Testing of Hypothesis 2. So, our Module 5 name is Testing of Hypothesis 2. Contents: definition and terminology, question bank of testing of hypothesis 2. So here testing of hypothesis is nothing but here test of hypothesis for small samples. In test of hypothesis for small samples, we have only 3 topics are there. So first one is T distribution or T test. Second one is F distribution or F test. And third one is chi-square distribution or chi-square test. So in T distribution, again we have 2 methods. So first one is T test for single mean, and second one is T test for difference of means. So in test of hypothesis 2, we have test of hypothesis. This is nothing but test of hypothesis for small samples. In this, we have 3 topics are there. First one is T distribution, and second one is F distribution, and third one is chi-square distribution. In T distribution, we have 2 methods. First one is T distribution for single mean, and second one is T distribution for difference of means. Okay, so first one is T distribution for single. So now we will discuss about definition and terminology on test of hypothesis 2. That is test of hypothesis for small samples. So first question is, classify the small sample. If the sample size is less than 30, then we can say that there is small sample. So we know that the sample size is denoted with n. So if n is less than 30, then we can say that that is small sample. Next definition. Express the formula of degree of freedom for students' T distribution for single mean. T distribution and students' distribution both are same. The students' distribution, T distribution for single mean is here. The degrees of freedom for students' T distribution for the single mean is n-1 degrees of freedom. So that means here we have to take T alpha at nu equal to n-1 degrees of freedom. T alpha at nu equal to n-1 degrees of freedom. Or we can take, for accurately, we can take T alpha by 2 at nu equal to n-1 degrees of freedom. So this is the formula for degrees of freedom for student T distribution for single mean. Next, coming to the next question, describe the degrees of freedom. So what is the definition of degrees of freedom? So the number of degrees of freedom is the number of values in the final calculation of statistic that are free to vary. So here these are all the degrees of freedoms. So in T distribution, we have n-1 degrees of freedom. In T distribution for single mean, we have nu equal to n-1 degrees of freedom. In T distribution for difference of means, we have n1 plus n2 minus 2 degrees of freedom. So like that, in F distribution, we have nu1 equal to n1 minus 1 and nu2 equal to n2 minus 2. n2 minus 1 degrees of freedom. So these are all degrees of freedom. So next one, narrate about the conclusion in the testing of hypothesis. So what is the conclusion for test of hypothesis or testing of hypothesis? If the calculated value is less than or equal to tabulated value, so then we accept the null hypothesis. If the calculated value is greater than tabulated value, then we reject the null hypothesis. Or let us take T distribution. So if in T distribution, if T alpha is less than, if modulus of T less than T alpha, so this is a calculated value. Here we have to use the formula, T distribution formula. So if our calculated value is less than tabulated value, or less than or equal, no, that is less than tabulated value. If the calculated value is less than tabulated value, then we can say that we accept the null hypothesis. We accept H naught, null hypothesis. If modulus of T greater than T alpha or T alpha by 2, so then we reject our null hypothesis. So that is the conclusion of testing of hypothesis. So this is the example. Now, analyze the student's T distribution for single mean. So consider a sample of size small n with mean x bar and variance s square is taken from the population having mean mu and variance sigma square. So then T distribution for single mean is T equal to x bar minus mu by s by root n. So this is the formula for students' T distribution for single mean. Here T alpha by 2. Here we have to take the level of significance. So T alpha at nu equal to n minus 1 degrees of freedom. Now coming to the next question. Analyze the student's T distribution for difference of means. So for this, consider a population mean mu and variance sigma square. If we choose two samples from the population of sizes n1 and n2 with means x1 bar and x2 bar and variances s1 square and s2 square. So therefore, the T distribution for difference of means T equal to, so x1 bar minus x2 bar divided by s into under root of s into under root of 1 by n1 plus 1 by n2. So this is the student's T distribution for difference of means. Here T alpha at nu equal to, we have to take n1 plus n2 minus 2 degrees of freedom. Next definition. Illustrate F distribution. So to test whether there is any significance difference between two sample variances s1 square and s2 square, we have to use F distribution. If there is any significance difference between two sample variances, then we can use that F distribution. Here F equal to s1 square divided by s2 square, where s1 square greater than s2 square, or F equal to s2 square divided by s1 square, where s2 square greater than s1 square. So this is the formula for F distribution. Next, coming to the chi-square distribution. Illustrate the chi-square distribution. So to test there is any significance difference between observed frequency and expected frequency. Observed frequency and expected frequency, then we can use chi-square distribution. So the chi-square distribution formula is here chi-square equal to summation y minus ei whole square by ei. So this is the formula. Summation y minus observed frequency minus expected frequency. Y is nothing but here observed frequency. observed frequency, and EI is expected frequency. Expected frequency. Okay, so the chi-square distribution formula is chi-square equal to summation y minus EI square whole square by EI. So what is the definition? If there is any significant difference between observed frequency and expected frequency, we can use chi-square distribution. Okay, so next question. Describe the chi-square distribution for goodness of fit. So this is also same. So whether there is any significant difference between observed and expected frequencies, to use chi-square test, here also same. The formula is chi-square equal to summation y minus EI whole square by EI, or sigma y minus EI whole square by EI. So this is the formula for chi-square distribution for goodness of fit. Here we have to fit two cases. First one is we have to fit for binomial distribution, and also we can use for Poisson distribution. We can fit the Poisson distribution. So we have to use the expected frequency. So for the goodness of fit, we have to find the expected frequencies. Expected frequencies. So the formula for expected frequency is n into p of x equal to x. So if we are using for binomial distribution, no, so then n equal to, this will be ncx p power x q power n minus x. So if we want to find the expected frequencies for Poisson distribution, no, the formula is n into p of x equal to x. So that means here we have to use the Poisson distribution formula, that is e power minus lambda power x by x factorial. So that is chi-square distribution for goodness of fit. Next question. Describe the chi-square distribution or chi-square test for independent of attributes. So here we use the test if two attributes under consideration is independent or not. So we use this test if two attributes under consideration is independent or not. So in this case we have to find the expected frequencies. We have to find the expected frequencies, because in chi-square distribution the formula is chi-square equal to summation y minus EI whole square by EI. So where y is nothing but observed frequency and EI is nothing but expected frequency. So how to find the expected frequencies in independent of attributes? In independent of attributes, we have to use the expected frequencies by using row total. So here I write the expected frequency equal to row total into column total divided by grand total. Grand total. So this is the formula to find the expected frequencies in chi-square distribution for independent of attributes. So coming to the next question, state the degrees of freedom for students' t distribution for difference of means. So the students' t distribution for difference of means formula is t equal to x1 bar and x2 bar, x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So here s square equal to 1 by n1 plus n2 minus 2 into summation xi minus x1 bar whole square plus summation xi minus x2 bar whole square. So this is the formula for s square, variance. Okay, so where t equal to, so t is nothing but test statistic, t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So here we have to take the degrees of freedom for t distribution for difference of means is n1 plus n2 minus 2. That means here we have to take t alpha by 2 or t alpha at nu equal to n1 plus n2 minus 2 degrees of freedom. Next question. State the formula for degrees of freedom for students' F distribution. State the formula of degrees of freedom for F distribution. F distribution, not students. That is F distribution. The degrees of freedom for F distribution is n1 minus 1, n2 minus 1. So nu1 equal to n1 minus 1 and nu2 equal to n2 minus 1 degrees of freedom. Or we have to take the degrees of freedom like F alpha at nu1 comma nu2 degrees of freedom. So that means F alpha at nu1 is nothing but n1 minus 1 and nu2 is nothing but n2 minus 1 degrees of freedom. So coming to the next question. The 13th question is, state the formula of degrees of freedom for chi-square distribution. So the degrees of freedom for chi-square distribution is n minus 1 and the formula is chi-square equal to summation y minus ei whole square by ei, where y is nothing but observed frequency and ei is nothing but expected frequency. And the degrees of freedom. So here we have to take chi-square alpha at nu equal to n minus 1 degrees of freedom. Next question. Narrate the significance for small samples. So, the study of test of significance is the deviation between the observed sample statistic and the hypothetical parameter value is significant, and the deviations between two sample statistics are significant. So, this is the significance for small samples. And the last question is, state the formula of degrees of freedom for chi-square distribution of attributes. So, the degrees of freedom for chi-square distribution of attributes is row minus 1 into column minus 1. So, that means here we have to take chi-square alpha, we have to take the level of significance. The level of significance is here chi-square alpha at nu equal to row minus 1 into column minus 1 degrees of freedom. So this is about testing of hypothesis 2, that is nothing but test of hypothesis for small samples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.